Welcome back to our next lesson. This lesson begins on page 10 in your notes. I'll jot that there. Okay, page 10. And this one is called the half-angle formula. And this is the third and final type of formula that you're going to be using for trigonometric identities. Half-angle formula, of course, because if you look at the formula carefully, you have the sine of alpha over 2. There's your formula for the half angle of a sine half angle formula. Notice it starts with a plus or minus, though. Now, you have to be careful there because depending on which quadrant alpha over 2 ends up in, this could be a negative value or it could be a positive value, and you have to decide which of the two signs you're going to use. Are you going to use positive or negative? The actual formula itself is the square root of 1 minus cosine alpha over 2. All right, again, you don't have to memorize that formula. They're provided on your sheet. Here, down below that, is the formula for the half-angle cosine. All right, so cosine of alpha over 2, again, you have this plus or minus in front. You have a decision to make which of the two versions you use depending upon which quadrant alpha over 2 ends up in. The formula itself, though, looks very similar to the sine half-angle formula, doesn't it? The only difference being in sine, the numerator is 1 minus cosine alpha over 2, and for the cosine half-angle formula, you have 1 plus the cosine of alpha over 2. All right? So let's have a look at the types of questions that you could be asked here using the half-angle formulas. Now the first one on page 10, right here, question number 1, is actually pretty basic. This one is pretty simple. All it says is to simplify, do not evaluate. And if you look at it carefully, when you're asked to simplify, you have a big square root sign, 1 minus cosine of some angle divided by 2. Now, where have I seen that before? Well, it's actually, if you look right up here, it's actually the sine half-angle formula, isn't it really? 1 minus the cosine of some angle. In this example, your alpha is 114 degrees. That's what it shows us in our formula, you see? 1 minus the cosine of alpha. So alpha is equal to 114 degrees. So if we were to simplify, in other words, just go backwards in our expression, this should equal the sine of, when alpha is 114, so that's 114 over 2. So it is equal to the sine of 57 degrees. There you go. You've simplified it. Now notice it said do not evaluate, so you don't need to type that into a calculator or anything like that. They're just asking you to recognize that those two expressions are equal to each other, okay? All right, here's number 2. Here's question number 2. Now this one is not a proof. This one involves finding the value of cosine alpha over 2. So excuse me, if you come back up and look at your formula again, there is the formula that you're going to be using to solve this problem, the half-angle cosine formula. Again, we're not sure if it's positive or negative yet, but I'll show you a nice little way that you can determine whether it's positive or negative. But you're going to be using the square root of 1 plus cosine alpha over 2. That's what you're going to use here. Now, the only thing is, wait a minute, cosine alpha over 2, they don't give us cosine of alpha, do they? They don't give us cosine of alpha. They give us the sine of alpha. Now, we have in a previous couple of lessons, we've seen how we can find the sine or the cosine of any angle if we're given the other ratio and if we know which quadrant that the angle is in. So look at this. If angle alpha is between 180 degrees and 270 degrees, that means it's in quadrant number 3, isn't it? That's quadrant 3. Just write a Q3 there. If that's in quadrant number 3, and of course the sine is negative in quadrant number 3, then we should be able to easily set up a diagram, just like we did before in a couple of the other ones, a couple of the other types of examples. slap down a quadrant 3 angle, something like that. There you go. That's quadrant 3. Your alpha actually goes all the way around to there. That's your alpha because it's in standard position. But here's your reference angle right there. And you're going to use that reference angle now when you're determining like where to put the -4 and where to put the 5 from the sine of alpha. Sine, remember, is opposite over hypotenuse. So the opposite side is your -4. That goes right there. And it is negative, yes, because that side is coming down from the x-axis. All right. And the hypotenuse is the bottom number. So that would be my 5 right there. And just like the types of problems we did before, you can see that there's a missing side there. Now, I usually just call it W, but you call it whatever you like. You can use X here in this case if you want. X is not used anywhere else in the problem. So, again, Pythagorean theorem, and this is straightforward. You've done this before many, many, many times. W, or 5 squared is equal to W squared plus -4 squared. All right. Or you could just say 4 squared because the actual length of it is 4. Negative just refers to the direction that it's going in. So anyway, if you solve this, everybody, you're going to get 25 is equal to W squared plus 16. All right. You bring your 16 over. 25 take away 16. I'm pretty sure that's a 9. So W squared equals 9. So your W is actually going to be 3. Now, wait a minute. It's actually plus or minus 3, isn't it? Now, the length of it is 3, yes. But if you look at the side W represents, it's actually going to the left. You see that? That side is going to the left of the origin. So we have to consider it to be negative. And that, of course, means that the cosine, which we don't know, the cosine of alpha is, let me see now, that's my -3 right there, equals -3. So the cosine is adjacent over hypotenuse. That would be -3 over 5. And that's what we put into our formula now. All right. So here we go. Watch carefully. Cosine of alpha over 2 is equal to, now wait a minute. Go back and look up at that formula again. Plus or minus in front. All right. Now, alpha over 2 is not in the same quadrant that alpha was in. Alpha itself was actually in quadrant 3, remember. According to the problem, we were told that alpha was in quadrant number 3. So where is alpha over 2 going to end up? And you know what? It might not be obvious. All right? Is it going to end up in quadrant 2, or is it going to end up in quadrant 1? Or like, what would half of this angle, where would it end up to? Well, there's a really, really, really simple way to figure that out. Which quadrant alpha is going to end up in. So watch what I'm going to do here. This expression right there, that's the expression for alpha, isn't it? Well, you can easily change that into an expression for alpha over 2 if you divide every term there by 2. Watch that. See that? Divide every term there by 2. So that tells me, now 180 divided by 2, that's 90. 90 degrees is less than alpha over 2, which is less than, and 270 divided by 2, that's 135. Now you see that? There, that tells you where alpha over 2 is located. And 90 degrees up to 135, that's quadrant number 2, everybody. So alpha over 2 is in quadrant number 2. And that's how you decide whether to use the positive or the negative. All right? So quadrant number 2, right there, that's a quadrant 2 angle, and the cosine of a quadrant 2 angle, everybody, according to your CAS rule, is negative. There you go. So that tells you whether to use the positive or the negative in the formula. The other part of the formula, of course, is 1 plus cosine alpha divided by 2. And now basically this problem boils down to just plugging in -3 over 5 for alpha over 2. Or sorry, just for alpha, because we just worked that out a minute ago, remember? So you're going to get negative square root of 1 plus, now, negative 3/5 divided by 2. And now the rest of this question, you'd get most of your marks for doing that. This is worth most of the marks here now. The rest of it is just simplifying that in under the square root sign a little bit, all right? So 1 plus negative 3/5, that's the same thing as 1 minus 3/5. Now you could do this with your calculators. That's going to be 2/5 divided by 2. And 2/5 divided by 2 is the same as 2/5 multiplied by 1/2. So that's going to give you the negative square root of 1 over 5. Now, I'd probably accept that as the answer. You'd certainly get most of your marks for that. The only other thing to remember, though, is that like with radicals, now you've done radicals. You did radicals back in Math 1700. You're not supposed to end up with a fraction in under a square root sign. You see? That's supposed to be a no-no. Well, if you broke this apart into the negative square root of 1 over the square root of 5. Now, the square root of 1 is just 1, but then you'd have to rationalize your denominator by multiplying the top and the bottom by root 5. And so the best answer, the most simplified, perfect answer, I guess, would be negative root 5 over 5. There you go. See that? Now, that is the proper answer. That's what it should be right there. Okay. I'll wait for you all to copy that down. Or you can just pause the video and write all that down if you like. And but that's how you do those. So you probably will. You might see one of those again on a quiz or on a test. And there's one more question here now that involves half angle formula. And it's on the bottom of page 10, and it is a proof. Now, look at that. I'm going to erase some of this stuff here now, get it out of the way. Like I say, you can pause the video and copy all that down if you like. All right, but I'm just going to erase that and make some space here now so I can do a proper job with that last example there. That's a proof. And that one is what I call a doozy. That is definitely a doozy. All right, he can be tricky. Oh my goodness, look at that. What are we going to do there? What are we going to do there? Well, I can see, if you look at it carefully, everybody, you have to prove that the sine of alpha over 2, that's a half angle, isn't it? Is equal to 1 minus cosine alpha divided by 2 times the sine of alpha over 2. Again, look at that. My goodness. Alpha over 2 again. That's a half angle again. Now, obviously, I think the more complicated looking side is the right-hand side this time. So you could start here with the right-hand side, and the first thing you'd have to do is, my goodness, look at this. You'd have to replace the sine of alpha over 2 with plus or minus the square root of 1 minus cosine alpha over 2. You know what? That's hard. That's long. That would be like a really, really, really complicated proof. In fact, I did the proof using that substitution. And it took me, I would say, about anywhere from 8 to 10 steps to do the proof using this method. So I tell you what, I'm going to make life a little easier for you. I'm going to make life a little easier. You watch carefully what I'm going to do. And what I'm going to show you now, you can use this technique, usually anyway, like 90% of the time it works, if you have to do a proof involving a half angle formula. I'm going to make a substitution here. Watch carefully. You see, these alpha over 2's, they're going to make life really, really, really hard. So I'm going to do this. Watch carefully. I'm going to let alpha over 2 equal, now you pick another angle. Pick a different symbol. It doesn't have to be an angle symbol. You could use theta. You could use A, B. Use whatever you want. I'll tell you what, I'll pick theta. I'm going to make that substitution, everybody. Now, wherever in the proof itself, wherever in the first proof over here, wherever I see alpha over 2, I'm going to replace that with theta. So you see the proof is going to turn into the sine of just theta. This thing right here is going to turn into just theta as well. Now what about the alpha itself though? Well, if you take this expression right here, to get alpha by itself, you multiply both sides by 2. So alpha is actually equal to 2 theta. Now you see that? So this alpha right there becomes 2 times theta. Now if you make all of those substitutions, everyone, if you make all of those substitutions in your proof, you end up with what's called an equivalent proof. Proving the equivalent proof is identical. It gives the same result as proving the original proof that you're trying to verify. And believe me, it's much, much, much easier. So we're going to take this and just rewrite it. And like I say, this procedure, this technique usually works, oh my goodness, like 90% of the time. So we're going to change it into prove. Now remember, alpha over 2 is a theta. So prove that the sine of theta. Now look how easy that side looks. That looks pretty simple, doesn't it? And then over on the other side, I'm going to have 1 minus the cosine of. Now, in place of the alpha, remember, you put 2 theta. And there you go. Divided by 2 sine. And now in place of alpha over 2, I just put a single theta. Now look at that. Still looks like it might be a little bit tricky, but believe me, this is far, far, far easier than the proof involving the double angle. So let's take the most complicated looking side, and that's obviously the right side. That's what we'll start with. And you watch what happens here now. You're going to be so glad that you did this. The right-hand side is equal to 1 minus cosine 2 times theta divided by 2 sine theta. Now, where do you go from here? Well, ladies and gentlemen, you see this? You didn't avoid using some formula altogether. Now you have to use a double angle formula for cosine, right there, okay? Excuse me. But you want to use a version, again, notice what you're trying to prove it equal to. Come back up here. There's the left side. So wouldn't it be nice if we ended up with something that involved just sines and no cosine? I think 2 of the versions of the formula does that. Let's go back and look at them right there. Look at that. Look at that very carefully. Which formula has sines in it, but not cosines? I think we're going to try this one right there. 1 minus 2 sines squared. So let's go back to the proof. I'm going to say this is equal to 1 minus, and now in brackets, don't forget your brackets, 1 minus 2 sine squared. Now the angle here is theta. All right, so I'll put my theta in. Divided by 2 sine theta. Your next step obviously would be to remove the brackets. And now there's a minus in front of those brackets. So obviously that's going to change the signs of what's inside, right? So it's going to become 1 minus 1 plus 2. Oh my goodness, look how easy this is now. 2 sine squared theta over 2 sine theta. Those two things cancel. You're basically left with 2 sine squared theta over 2 sine theta. Everything is factors here. Everything is multiplied together. You can cancel away to your heart's content. The 2's are gone. This sign in the denominator will cancel with one of the signs on the top. And look at that. You have now proven the equivalent proof. Look at that. It's equal to just sine theta. And that's what we have. So now that is equal to the left-hand side. And by golly, look at that. We got the right-hand side equal to the left-hand side. And below, this is much, much, much simpler than the original proof involving the half-angle formula. Believe me, it really, really is. Okay. Now, this marks the end of the different types of formulas that you have to look at. Trigonometric identities. So remember on the last lesson or the lesson previous to that, I assigned some of the questions on pages 11 up to 15 to work on. So I'm going to suggest, here's some more now that you can try. All right, so here's some more practice ones. Basically the ones that I didn't give you the other day. That's the ones I'd like you to try right now. But you can do these now. Number 6, number 8, numbers 11 to 15. And these are on pages. These are on pages. Let me make sure I got the pages correct. Yep. These are on pages 12 to 14. 12 to 14. Okay. Now, before I finish this video, there's one other thing I want to mention. Now, if you look at the examples, the practice ones on page 11, all right, proofs, 12, there's a proof. They're basically all proofs. There's the angle, look, the difference formula right there. Double angle formula and double angle formula. All right, that one looks pretty basic. Half angle formula. Make that substitution that I did right there. Substitute. Just say alpha equals theta over 2. The other ones look pretty straightforward. They look pretty straightforward. They look pretty straightforward. Okay, now there's one proof, this one, the very last one. Now this is on page 14. When you try this one, I'm going to suggest that you do not make the substitution that I told you about, all right? Do not say let alpha equal theta over 2. You go ahead and just do this proof the way it is. Actually use the half angle formula there for cosine. But the reason that this time is not very difficult, it works out really easily, is because look at that. You see that? You're going to square it. And when you square that big square root symbol, it kind of cancels each other out. So you don't end up with a square root here. Don't use the substitution that I just showed you a moment ago for number 5. You go ahead and do that proof just the way it looks. And I'll stop this video there. And that's it for identities. And our next video, we're going to come back and we're going to actually be starting on graphs of trigonometric functions. More fun. More fun. Okay, so I'll stop there and I'll see you in our next video. Bye-bye.